We are learning about box and whisker plots, or as I like to say, box and whisker. I've got a handy dandy example of a box and whisker plot right here on this slide. So you'll notice that it has a box in the middle of our data, and then it has a whisker on the left and a whisker on the right, thus the name. So it looks a little bit interesting, I hope, to you. I hope you're intrigued. And it is probably the most complicated graph that we're going to learn. And let's get started. This lesson will probably be the lengthiest lesson, so buckle up. All right, here we go. You have a set of Google Notes that I want you to complete on each slide for me. So let's jump in. Step one, when we are creating a box and whisker plot, rule number one is that you're always going to put your data pieces in order from least to greatest. Step two, you're going to identify 5 different points. So we're going to always find that middle number, which we call the median of our data. We learned that earlier last week. Then you're going to find the smallest number in your data set, which of course would be called the minimum. You're going to find the largest number, so we call that the maximum data piece. We're going to find the middle of the first quarter of data. We call that the lower quartile. And then we're going to find the middle of the fourth quarter data, and that is what we call the upper quartile. So now that we have some new vocabulary words, let's talk about what we're going to do as we're making these graphs. So when we find the middle number, you know that when you look at your data, you can, I always kind of block off, go one, then the other like this, and I find my middle piece of data. So that's my median. Our median is actually called Q2. Then you're going to find the median of your upper half. So you're going to look at, I have 3 data pieces over here, and we don't count this Q2. So we're going to look at these 3 data pieces, and I'm going to pick the middle of that one. So in this case, that would be 40, and that's going to be my Q3, my third quartile, my upper quartile. Then I'm going to look at the bottom half of my data, and right now I only have 3 pieces of data in it, and I'm going to pick the middle of that, and that's my Q1, or my lower quartile, or my Q1. Next, we're going to find the minimum and the maximum of our data set. So I'm just always going to know where the minimum and the maximum are. So I've underlined them on this data set. When you're making a line plot, or excuse me, a box and whisker plot, you're going to clearly draw a number line. Then you're going to plot the 5 points that I have indicated here and in your notes. Now this next part is a little bit long, but we're going to draw a box around our Q1 and our Q3. We're going to draw little whiskers to our lower points and our higher points, and then we'll always draw a line in the middle of our Q2. So let's work an example together, but I want you to have this information with you, so please type this down in your notes and refer back to them as you work on your assignment. So let's work on our first example. So let's just say we're given this data set. We have all of these numbers. First step is I'm going to put them in order from least to greatest. So I've actually taken the liberty of doing that, and I've listed all of our data right here in red. Go ahead and do that yourself. And then we're going to find the median of that data set. So as I'm looking through, I'm marking off one and then the other until I get to the very middle piece of data, which is, in this case, a 75. Now I'm going to look at the upper half of my data set. So my upper half of the data, it goes from 80, 82, 85, 90, and 95. And I'm going to pick the very middle number of that upper half. Well, that number is 85. That now is my upper quartile, or my Q3. I'm now going to look at the lower half of my data, and I'm going to look now at these 5 pieces of data. And I'm going to pick the very middle number, and in this case, it's a 68. My minimum number of this data set, I'm just looking to the far left, and that is a 50. I'm looking at the far right for my maximum, and that's a 95. So now I'm going to plot these numbers. I've got my 5 numbers. I'm going to plot them. So first and foremost, I'm going to, and by the way, guys, do not worry about filling in this slide electronically. This took me probably about a good 30 to 45 minutes just to plot all these numbers on here. Do not worry about this part. Just listen and watch. So as we move on, I plotted my smallest number, which was 50, my highest number, which was 95. Then I plotted my very middle number, which in that case was a 75. So all I've done is I've plotted those dots. Now I'm going to go back and plot my other 2 dots, so the 68 and the 85. So I've got 5 dots on my graph now at this point. Next, I'm going to draw lines through the middle 3 dots, just like I've done right here. Then I'm going to draw a box around them. Guys, this middle range is my interquartile range. I'll explain what that is in just a minute. Then I'm going to draw a line from my minimum number to the box and my maximum number to my box. So let me explain to you and how this is interpreted. The middle set of our data, the 50%, is in the box. That's our interquartile range. Every quartile then is indicated here in blue. You can see that I have my first quartile that's from the minimum point to here. So I've got, this is my first quartile. My second quartile, or the second 25% of my data, is here. The third 25% of the data is here, and the very highest part of my data is over here, where is the fourth quartile. Now, I'm going to show you that this is Q1, Q2, and Q3. We refer to those points as Q1, Q2, and Q3. Inside the box, we call that the interquartile range. And if somebody asks us, what is the interquartile range? We can take the number Q3 and subtract the number of Q1 and get the actual range. So in this case, I've got 85 minus 68. And so we're definitely going to, we'll have 17 is our interquartile range in this case. Okay, I'm going to move on now to some examples. Example number 1, and this is from IXL, your IXL lesson. So this is a box and whisker plot, and it's asking you to interpret this data. So these are all of the air traffic controllers, and when these are the flights that they're looking at. And the question says, what % of the cities have 40 or more flights departing each day? Well, guys, all of our data is from here, from 40 on up, right? And so this range right here is about 25% of our data. This is 50% of our data, and this is another 25% of our data. So the entire from 40 and above is 75% of our data. So our answer for this question would be 75%. I'm going to move on to our second example here. And this particular question is about textbook costs. So this is a community college, and this is the amount of money that people are spending on their textbooks. So we're looking at this data, and it asks the question, what is the value of the interquartile range? So folks, what this is asking is, what is this number here to this number? Well, when I look at my graph, I can see that it's in intervals of 50. There's 300, this is 350, 400, 450, and then 500. So I'm going to take this number, which is 450, and I'm going to subtract 350. So my answer for this interquartile range is 100. Okay. One of the things on the STAR test, which of course you're not taking, but it is being able to compare box and whisker plots. So you've got to be able to interpret the data and interpret each of these kinds of graphs. So this is a phone company, and they found an error in their billing system. And so this is April's landline phone bills, and they're comparing a couple of different cities, Landberry and Middletown. So the question asks, which city has the maximum value that is lower? Okay, so it's asking about this maximum value. It's asking about this far right value over here. And it's just saying which one is lower. So this Landberry value is the lowest one. So in our example here, I'm going to click on Landberry because it has the lower maximum point. Okay, I think you're ready to interpret these kinds of graphs. This assignment is BB16. I wish you well, and as always, let's do some math.